What if I told you that right now, as you're watching this video, there could be alien life thriving in underground oceans, surviving in methane lakes, or even floating through acidic clouds? We're not talking about science fiction, we're talking about real worlds in our own solar system and beyond, where the conditions for life might be better than we ever imagined. I'm Aria, and welcome back to Planetary Possibilities, where we explore the incredible worlds that could change everything we know about life in the universe. Today, we're diving into 5 extraordinary worlds that scientists believe could harbor life. Some might surprise you, others might terrify you, but all of them will make you question what we really know about life beyond Earth. Before we blast off to these incredible worlds, let's establish what we're looking for. When scientists search for life, they're not necessarily looking for little green men. They're looking for the basic ingredients: liquid water, energy sources, and the right chemical building blocks. But here's where it gets fascinating. Life on Earth exists in the most extreme conditions imaginable. From boiling hot springs to frozen Antarctic valleys, from the crushing depths of ocean trenches to highly radioactive environments. If life can survive in these places on Earth, imagine what's possible elsewhere. Our first destination takes us to Jupiter's moon Europa, a world that looks like a giant ice ball but hides one of the most promising secrets in our solar system. Beneath Europa's frozen shell lies an ocean that contains more water than all of Earth's oceans combined. We're talking about a global ocean that's been liquid for billions of years, kept warm by the gravitational forces of Jupiter literally squeezing and stretching this moon like a stress ball. But here's what makes Europa truly special. Its ocean floor likely has hydrothermal vents, just like the ones on Earth where life first emerged. These vents spew out minerals and heat, creating the perfect chemistry lab for life to develop. NASA's Europa Clipper mission, launched in 2024, will fly by this moon multiple times, using ice-penetrating radar to map the ocean beneath. Some scientists are so confident about finding life here that they're already planning missions to drill through the ice. But Europa isn't just promising because of its ocean, it's promising because it's been stable for billions of years. That's enough time for complex life to evolve in those dark alien waters. If Europa is the cautious scientist's choice, then Enceladus is the thrill-seeker's dream. This small moon of Saturn is literally spraying evidence of its potential for life into space. When NASA's Cassini spacecraft flew through the plumes shooting from Enceladus's south pole, it detected something incredible: organic compounds, water vapor, and even molecular hydrogen. That molecular hydrogen is crucial. It's the same energy source that feeds life around Earth's deep-sea hydrothermal vents. Like Europa, Enceladus has a subsurface ocean. But unlike Europa, it's giving us free samples. Those towering geysers are like natural boreholes, shooting ocean water directly into space where we can analyze it. The Cassini data revealed that Enceladus's ocean has the right pH balance, the right salinity, and the right chemical composition for life as we know it. Some researchers believe that if life exists in Enceladus's ocean, we might already have collected the evidence frozen in those ice particles that Cassini flew through. But here's the kicker: Enceladus is small, only about 500 kilometers across, which means its ocean is relatively shallow. If life exists there, it might be concentrated in a smaller space, making it easier to detect. Now let's visit a world so alien it challenges everything we think we know about habitability. Welcome to Titan, Saturn's largest moon and the most Earth-like place in our solar system. If Earth were frozen and soaked in gasoline. Titan has lakes and rivers, clouds and rain, seasons and weather patterns, but instead of water, all of these features are made of liquid methane and ethane. The surface temperature is a bone-chilling minus 290 degrees Fahrenheit. But here's where Titan gets really interesting. It has 2 potential habitable zones. The first is a subsurface water ocean, similar to Europa and Enceladus. The second is even more exotic, the possibility of methane-based life on the surface. Scientists have theorized that life on Titan might work completely differently than Earth life. Instead of using water as a solvent, hypothetical Titan, life might use liquid methane. These organisms would breathe hydrogen instead of oxygen and might even consume the organic compounds that rain down from Titan's thick atmosphere. NASA's Dragonfly mission, set to launch in 2028, will send a nuclear-powered helicopter to explore Titan's surface. It will search for signs of both water-based life in the subsurface ocean and methane-based life on the surface. Think about it. If life exists on Titan, it would prove that life can emerge under conditions completely different from Earth. It would revolutionize our understanding of biology itself. Let's leave our solar system and travel to the closest exoplanet to Earth, Proxima Centauri b, just 4.2 light-years away. In cosmic terms, that's practically next door. This rocky planet orbits in the habitable zone of Proxima Centauri, a red dwarf star. It's the kind of world where liquid water could exist on the surface, if it has the right atmosphere. But Proxima Centauri b faces unique challenges. Red dwarf stars are notorious for violent flares that can strip away a planet's atmosphere. The planet is also tidally locked, meaning one side always faces the star in permanent day, while the other side is locked in eternal night. However, recent computer models suggest that if Proxima Centauri b has a thick atmosphere, it could redistribute heat from the day side to the night side, creating a twilight zone around the planet's edges where temperatures might be just right for liquid water. Even more intriguing, in 2019, astronomers detected mysterious radio signals coming from the direction of Proxima Centauri. While likely natural phenomena, these signals remind us that our nearest stellar neighbour might hold surprises. The James Webb Space Telescope is already beginning to analyse exoplanet atmospheres, and Proxima Centauri b is high on the target list. Within the next decade, we might know if this world has the atmospheric conditions necessary for life. Our final destination might be the most controversial on this list: Venus, Earth's evil twin. With surface temperatures hot enough to melt lead and atmospheric pressure 90 times greater than Earth's, Venus seems like the last place you'd expect to find life. But in 2020, scientists made a discovery that changed everything. They detected phosphine gas in Venus's upper atmosphere, a compound that, on Earth, is only produced by living organisms or extreme industrial processes. About 50 kilometers above Venus's hellish surface, conditions are surprisingly Earth-like. The temperature is around 60 degrees Celsius. The pressure is similar to Earth's, and there's plenty of water vapor. Could microorganisms be floating in Venus's clouds? Carl Sagan himself proposed this possibility decades ago. He imagined balloon-like organisms that could float in Venus's atmosphere, using sulfuric acid as we use water. Recent discoveries of extremophile organisms on Earth that thrive in acid make this seem less impossible. Multiple space agencies are now planning missions to Venus, specifically to search for signs of life in the atmosphere. The European Space Agency's Envision mission and NASA's Da Vinci Plus will both investigate Venus's mysterious atmospheric chemistry. If life exists on Venus, it would be the most extreme example of life's adaptability we've ever discovered. It would mean that life can survive in conditions we previously thought were impossible. From Europa's hidden oceans to Venus's acidic clouds, from Enceladus's geysers to Titan's methane lakes, from Proxima Centauri b's alien sunsets to possibilities we haven't even imagined yet. We live in a universe teeming with potential. Each of these worlds represents a different answer to the question, what is life? Europa and Enceladus show us that life might thrive in dark oceans beneath ice. Titan suggests that life might use completely different chemistry than Earth life. Proxima Centauri b reminds us that there are billions of potentially habitable worlds beyond our solar system, and Venus challenges us to expect the unexpected. The search for life beyond Earth isn't just about finding aliens, it's about understanding our place in the universe. Are we alone, or are we part of a cosmic community of life that spans the galaxy? Over the next decade, Missions like Europa Clipper, Dragonfly, and the James Webb Space Telescope will bring us closer to answering these questions. We might be living in the generation that discovers we're not alone. What do you think? Which of these worlds do you think is most likely to harbour life? Let me know in the comments below. And remember, we explore new worlds and new possibilities every week here on Planetary Possibilities, so make sure you're subscribed with notifications on. Until next time, keep looking up, keep wondering, and keep exploring the planetary possibilities that surround us every day.